C4H Weathering Change Seminar Series. Today's speaker is David Lyon, who is a senior methane scientist too at Environmental Defense Fund, and will be presenting how emerging or measuring and mitigating oil and gas industry methane emissions with emerging technologies and innovative policies. I would like to share a few announcements before we begin. Attendees will be muted until the Q&A portion of the seminar, where you will then be able to unmute and ask questions. During the presentation, you can add questions to the chat if you'd like, but I'll still probably call on you. You will receive an email after the seminar is over that has an evaluation link as well as links for the C4 website and YouTube playlist. You can also view upcoming events and recordings of past seminars. If you would like to join the C4 membership list to receive emails about these events, as well as the monthly newsletter, you can add your email address in the seminar's evaluation, where you can complete the form that Jessica will post in this chat. Thank you, David. I'll turn it over to you now.
All right, thanks, Kermit. Yeah, so for my presentation, first I'll be giving an introduction about myself, EDF, and methane, and then talk about EDF's over a decade of research on methane emissions from the oil and gas industry. Also talking about some of the relevance to health, human health, and then particularly talk about EDF's satellite Permian map. Then I'm going to go over a few emerging technologies, including satellite and remote sensing, stationary monitors, and then measurement-informed emissions reporting. And then finally, I'll talk about Moms Clean Air Force, EDF affiliated group that is focused on human health. So my background, I have a PhD in environmental dynamics from the University of Arkansas, and did my dissertation on oil and gas methane super emitters, which are relatively rare but very large methane emitters. In 2008 to 2012, I worked for the state of Arkansas, managing their air emissions inventory program. And then in 2012, I joined Environmental Defense Fund on the team working on oil and gas methane science. And I've been there since 2012, with the exception of 2023 and 2024. I worked a year each at the U.S. Environmental Protection Agency, and then the University of Texas, Austin, one of their energy institutes. And then moved back to EDF in 2025 with a particular focus on trying to defend a lot of the past methane regulations in the United States, then also working on policies in Europe and throughout the world. So if you're not familiar with EDF, we are a nonpartisan, nonprofit environmental advocacy organization. Currently, we have about 3.5 million members worldwide, and we're funded by membership fees and then philanthropic donations. And we have about 1,000 staff now working in 30 different countries. And where we really stand out from other non-environmental groups is we're guided by science and economics, and we're very solution focused. So rather than just opposing things, we come up with better alternatives that have less impacts on the environment and human health. And we work on a diversity of issues, so including oil and gas, methane. Also have lots of teams that work on climate and clean energy, oceans, ecosystems, and health. So first off, why are we focusing on oil and gas methane emissions? So first off, methane is a very powerful greenhouse gas that has about 86 times the warming potential of carbon dioxide on a mass basis over 20 years. And it's responsible for about 30% of the current warming around the globe. And global warming could be slowed by about 30% in the near term if the global methane emissions are reduced by 50% over the next decade. So really some huge opportunities to have a substantial impact on future climate change. So why the oil and gas industry? It's because methane is the primary constituent of natural gas. So therefore, when an oil and gas company is leaking methane, they're also losing product, and that often means they're losing revenue. So there's a lot of economic incentives for them to to capture the methane and sell it rather than venting to the atmosphere. And then finally, a lot of these methane emissions can be mitigated with very cost-effective technologies and operational practices. So often, once the companies understand what's causing the emissions, they can greatly reduce emissions for negligible cost, particularly since they're often gaining additional natural gas that they can sell by implementing these practices. So, so what are the health impacts of methane? So, methane itself is non-toxic, but it can impact surface ozone concentration. So, research has found that globally, methane can increase the ozone by about 1 ppb. So, not a huge amount, but definitely there are a lot of places where that 1 ppb can places make them above the air quality standards. Natural gas also has a lot of hazardous air pollutants in it. It can include hydrogen sulfide in some areas with sour gas. Also has benzene, other BTEX compounds, hexane. So lots of compounds that can harm human health. In addition to the direct emission of these compounds from leaked and vented natural gas, oil and gas industry often has a lot of combustion sources, both stationary sources such as flares and engines, and then mobile combustion sources such as drilling rigs or all the trucks that are transporting a lot of the oil. So these processes can also emit hazardous air pollutants. So EDF has been researching oil and gas methane since 2012. Right when I joined, I was a research analyst on our first research studies, and we've partnered with over 200 scientists and organizations in these studies, including the University of Cincinnati. So Dr. Amy Townsend Small from Environmental Studies and Sustainability has been worked on several of our research studies. Most of our studies use independent multiple methods to measure emissions. So to really increase the accuracy, we want to compare emissions with quantified with different approaches. And then most of the research is published in peer-reviewed journals. So far we are at over 100 publications that have resulted from our work. And then many of these studies have provided stakeholders with valuable data. So a lot of the oil and gas companies have been able to better understand and then reduce their emissions by the data provided in our studies. And also a lot of regulators have been able to come up with effective regulations. So this is a very collaborative process. Also mentioned that most of the studies involved oil and gas companies, so really was helpful to have them on board so we could get their expertise on kind of what's going on in the field and how that can impact emissions. And including a link there if you want to see more details, including I think it has a list of all the publications so far. Here's an odor diagram showing the original core 16 studies from EDF. So these studies were across the oil and gas supply chain. So we had some studies in looking at the production sector, which is a lot of the wells producing the oil and gas, and then the gathering and processing, which collects the gas from the wells and then often does some treatment with it to get it ready for pipelines. And the transmission and storage segment, which transports the gas across pipelines in the country. Local distribution, so a lot of the local utilities that provide natural gas to homes and businesses. Then we look also at some end uses, including CNG trucks and fueling stations. We've also done a lot of synthesis studies to try to come up with what does all this data integrated together tell you about the U.S. oil and gas supply chain. And then some, including abandoned wells that Dr. Townsend Small participated in, looking at a lot of these oil and gas wells that were abandoned by their operators. What are their impacts on emissions? So some of the major findings of these original studies is first that there's emissions throughout the supply chain, particularly the production and gathering or the upstream sector has very high emissions. but it can vary a lot by basin, and particularly oil-producing basins tend to have higher emissions. But we also found that traditional methods, often referred to as bottom-up, tend to underestimate emissions. So traditionally, this is an emissions inventory approach where you're just taking counts of things like number of wells or number of pneumatic controllers, and then you multiply those by some emission factor that's supposed to represent the average emissions of those types of components. But find out that a lot of these emission factors are too low, so these methods are underestimating emissions. And our synthesis paper, Alvarez et al. 2018, which was published in Science, found that at the time, the U.S. EPA, their official estimate of oil and gas methane emissions in the U.S. was about 50% lower than estimated by integrating lots of measurement-based studies. Another big finding is this thing on super emitters. So I found that really any type of oil and gas site type or source type you look at, if you look at the distribution of emission rates, you'll find that the top 5 to 10% highest emitting sources typically account for over 50% of the total emissions from those sources. Unfortunately, these high emitting sources do not tend to persist. They often are intermittent, short-term emissions that are coming from different sources. So at any one time, you might have different sites being the super emitters, and they're mostly unpredictable. So what this shows is you really need to have a lot of high frequency data looking at sites and sources so you can find these super emitters and quickly fix them. Another big finding is that while these super emitters account for about half of emissions, about another half of emissions are coming from low production or marginal oil and gas wells. So these are wells that have very low production rates, usually less than 15 barrels of oil equivalents per day. So we find that these wells have very high methane intensity. So often they're leaking about 10% or more of their natural gas production as emissions. So these wells can account for about half of the total production sector methane emissions, but they only account for about 6% of US oil and gas production. So by plugging these marginal wells to stop their emissions, that would be a way where we could greatly reduce the US methane intensity with only minor impacts on oil and gas production. Oh, and I will mention this photo on the bottom far right. I don't know if you can see, but it's a compressor station, and you can see a plume of what looks like water vapor coming out of one of these sources. So this was an example of methane emissions that were so large they were actually visible to the naked eye. Methane itself is invisible, but in this case, it's probably such a high emission rate, it's causing cooling and causing water vapor to condense out of the atmosphere so you can actually see it. So that's a massive leak. Let's see. Next, I'm going to, oh yeah, so I'm going to talk real quickly about this Permian map project that I led starting around 2020, 2021. So one of the other things we found from our core research studies is that while the data we were providing was very useful for companies to understand their emissions, it often was not timely enough for them to address like individual leaks. So we were trying to come up with the way to get the results from measurement studies to operators within a week or less rather than months or a year, so it would really be relevant for their current operations so they could reduce emissions. So for this project, we focused in the Permian Basin, which is in West Texas and Southeast New Mexico. It is now the largest oil producing basin in the US, tremendous amounts of activity in the area. So for the Permian Map project, we used several kinds of data, including to really understand emissions. So this included aerial approaches. So we had scientific aviation, which used a small plane to to basically circle groups of sites to measure the total emissions from those sites. We had remote sensing data from Carbon Mapper. We had Penn State University do tower-based regional estimates, University of Wyoming vehicle-based site level estimates, and Leak Surveys, a company doing helicopter-based optical gas imaging. So we show you some of these. So first, we were looking at the total emissions in the basin and how it changed over time. So this used the combination of satellite from the Tropomi instrument, Scientific Aviation's aircraft-based estimates, and then Penn State University had a network of 5 towers where they had methane monitors and were able to track weekly emissions. So we did find that emissions were changing quite a bit over time. And during COVID, when the oil price briefly dropped a lot, I think it actually went down to 0, or it had like a negative price at one day, meaning that producers would have to pay to get the oil out of the basin. You saw a pretty big drop in methane emissions during that period. So my hypothesis is that typically the Permian Basin just has so much new production that it's causing a lot of super emitters. And when operators stopped drilling wells due to the oil price drop, it caused a big drop in emissions. So showing that by slowing down production and making sure there's adequate pipeline capacity, probably could have a big impact on emissions in the region. University of Wyoming used their mobile lab to look at emissions from well pads. This also is really valuable because they have a PTR top mass spec, so they could get concentrations of lots of hazardous air pollutants from these oil and gas sites too. And then we used optical gas imaging, which is a type of infrared camera that can make the normally invisible methane visible. So we used a helicopter survey of thousands of sites. And what we found is one of the most common sources of emissions in the basin were unlit or malfunctioning flares. So on the right, showing a flare at a processing plant. It should be lit and having the gas burning to carbon dioxide, but in this case, it is out and the emissions are just being vented. So I found this is a very common problem in the region. And then finally, I think the most valuable data was aerial infrared remote sensing. I think I'll talk a little bit more about it later, but this is data that lets you actually image the plumes from above and then quantify. So this was the most useful because we could attribute most of these sources to the actual site and operator. So we were able to contact the operators and be like, hey, we saw an emission source at this site. And so it really was useful for them to mitigate those sources. So now I'm going to transition to talk about some of the new technologies that are being used. So there's a lot of these observing systems looking at oil and gas methane at different spatial and temporal scales. And what studies have found is that the most accurate estimates are based on integrating a lot of this types of data. So from all the way down from site level data, such as measuring the emissions of individual components with handheld meters, to things like vehicles and drones that are measuring more at the site level, or sometimes like a cluster of equipment, all the way to these aerial and satellite approaches that can estimate emissions at the regional level. So there are lots of aerial and satellite remote sensing data, and they have a very wide range of spatial scales and kind of how they're deployed. So some are more at mapping large emissions over large areas, and others are more for targeting super emitters. So now I mentioned Methane Sat. So EDF launched had an affiliate company, Methane Sat, that worked with several other groups, including Harvard University and the government of New Zealand, to design, build, and then launch a satellite. So Methane Sat was launched in 2024 to quantify methane emissions, both at the area level and from large point sources. So the satellite had about 130 by 400 meter pixels from a 200 kilometer swath that could image, and could detect point sources that are above about 500 kilograms per hour. So these are very large super emitters. So unfortunately, in June 2025, the satellite lost power and is dead. So no more data, but we did get over a year of data from the satellite, and it's been extremely valuable. And so now EDF is considering launching a new satellite and shows some of the results from methane sat. So this was looking at the gas normalized methane intensity. So what percentage of gas is leaking in various basins? You can find it's a very wide range across the world. So some places like in Iraq and Russia, where near 20% of the gas is leaking, and all the way down to the Appalachian, near where you are, it was actually the best performing basin. So I believe that was more 0.6%. So huge range in performance across the globe and even across the US. You can see San Joaquin Basin in the US and California is over 10%. So really critical that the emissions are distinguished at least the basin level, often the company level, to really differentiate this difference in performance among companies and basins. And now talk a little more about this aerial infrared remote sensing and LiDAR, like was used in the Permian map. So these are technologies that use, in the aerial IR sense, they're using basically reflected sunlight to look for methane plumes. And for LiDAR, they're using a infrared laser. So both these approaches can image the plumes. So on the left, I'm showing Carbon Mapper. Their aircraft has been monitoring the Rumpke, the Cincinnati's main landfill, and they have several measurements from it. Here's one, I think it's about 1,000 kilograms per hour coming from the landfill, but see that emissions have actually varied quite a bit during the various times it's been measured. And then on the right, you have Bridger Photonics. This is a company that uses LiDAR, has a very low detection limit of about 1 kilogram per hour, and is highly valuable for seeing emissions to more of the equipment level. So here you can see not only does it tell you which site, it will often tell you emissions are coming from like this tank or this flare. So really valuable for understanding the exact causes of emissions. And found out, this data is the most useful to operators because by seeing the source of the emissions, it really is a lot more relevant to them than just an emission rate. So I'll talk briefly about stationary monitors. I think this is the most innovative and still emerging approach. So stationary monitors are when you have sensors that are either at a site or sometimes here, the one that I showed a picture of, Long Path Technology, is a Boulder-based company that uses, it's essentially a infrared laser that's mounted on a tower, and it rotates, and then it shines the laser at retroreflectors at oil and gas sites that are located in about a mile or 2 radius around the tower. So it's able to measure at least dozens of sites from this central facility. So these stationary monitors are really useful for understanding emissions, but one thing to be clear is they're not exactly continuous. Sometimes they are called continuous monitors, and while they may be collecting data continuously, they're really only telling you about the target sites when the sensors are downwind of the emission sources. So due to wind directions moving about, sometimes these monitors have periods where they're really unable to tell you anything. But even this partial data can be really useful for understanding emissions. And what a lot of them do is in addition to collecting methane data, they can also get other operational data from the site, such as the gas pressure in various equipment. So these other data also is good indications of when you have some kind of malfunction that can cause emissions. And then particularly what's been useful is these monitors can estimate the duration of emission events. So the remote sensing approaches, while they're very valuable for quantifying the emissions, they don't tell you how long that source has been going. And find out a lot of these emission sources may be an hour or less. So really critical to understanding when they occurred to quantify the total emissions. And also, just mentioned, yeah, in addition to methane, these monitors can include sensors for things like BTECs that are really focused on the health impacts. So now I'm going to talk about a couple innovative policies that can reduce emissions. So first is the Oil and Gas Methane Partnership 2.0. This is a program that's part of the United Nations Environment Program Office, and it's a global measurement-based methane emissions reporting system for oil and gas companies. So currently there's over 150 companies from 90 countries that have joined the program, and they represent 45% of global oil and gas production. So companies that join OGMP, they commit to estimating their methane emissions with protocols that have increasing rigor. So eventually, I believe they have 2 or 3 years after joining, they need to estimate emissions with the level 5 approach, which requires collecting measurement data both at the source level and at the site level. So an example would be using more traditional component handheld meters to come up with what exactly is leaking at some of the sites, and then using things like remote sensing flights to come up with total site level emissions. Then the companies are required to reconcile this data, which is not exactly, it's not averaging in it or finding one that's more right than the others. It's more of evaluating where there's potential differences in the different types of data to better understand the profile of emissions, and then come up with the best estimate integrating data from both these sources. So this, yeah, it's getting increasing prevalence, and yes, now nearly half of the global production in this system. So it's influencing a lot of other policies, including the European Union's methane regulation will require imported natural gas, such as LNG from the US, to meet a methane intensity target. And this target must be based on, the methane intensity must be based on OGMP level 5 or equivalent protocols. So this is very important in the United States right now, since the Trump administration is rolling back a lot of the US methane regulations. So even if there are no longer US based laws that will require companies to reduce their methane intensity, they will have pressure to reduce it so they can export their gas to other countries with more rigorous regulations. And then talk about the U.S. methane emissions reduction program. So this was actually an idea that was developed by Steve Hamburg, the chief scientist at EDF, and then Senator Sheldon Whitehouse from Rhode Island. So they were talking and were wanting to come up with a way of really using measurement data to incentivize emission reductions. So the original idea was that you would use things like satellites and aircraft to come up with the total methane emissions from oil and gas in individual basins. And then the companies could either accurately estimate their emissions with things like that level 5 approach, or they would essentially be using bottom-up approaches and then scale up their reported emissions based on the basin level data. And there would be a charge, they have to pay a fee for their amount of methane emissions. So this would incentivize companies to use more rigorous emissions if they think that they had lower methane intensity than their peers in the basin. So there was a lot of interest in this program, but at the time, there was a 50-50 split in the Senate, and there was one Democratic senator who was more in favor of oil and gas industry. So we worked with the senator to change the bill, particularly to make it more based on the data reported to EPA's greenhouse gas reporting program rather than this basin level measurement data. And then also did a lot of changes like having exemptions for certain facilities and then sending more resources to particular types of wells and operators like small operators. So the overall bill that eventually was passed as part of the Inflation Reduction Act had three major components. So first was establishing this waste emission charge, which I believe started at $900 a ton of methane. The second part was it required EPA to revise the greenhouse gas reporting program for oil and gas to be based more on measurement data. And then finally, the third is EPA and the Department of Energy were given over $1 billion to award to various groups for methane monitoring and mitigation. So I was heavily involved in the passage of this law, and then this is why I actually moved to EPA for a year, was to help the agency do the revisions to the greenhouse gas reporting program, and then helped with the funding opportunities for methane monitoring and mitigation. Unfortunately, with the new administration, they delayed this program for 10 years. I think the intention is to kill it before those 10 years are up. So the program, the actual methane, the waste emissions charge was never implemented, but a lot of the funding was distributed to various groups. I will say the EPA and DOE haven't actually paid out a lot of this money yet, so we are working really hard to try to get the administration to actually award the funds, to give the funds to the awardees. But there is some good news. Did see from the last year of reporting data that a lot of oil and gas companies greatly reduced their emissions. And I think a lot of it was due to this. They were anticipating this methane fee, so they did a lot of changes so they would have not had to pay the fee. So I think that was successful in reducing emissions. And then it inspired the state of Colorado to do a similar program where they're using a measurement-based approach to come up with total basin emissions, and then modifying companies' reported emissions based on this empirical data. So while the federal program died, it I think did inspire methane reductions. And then I think this is my last slide. Just really wanted to mention Monmouth Clear Air Force for this group. So this is it's an EDF affiliated group. It's branded separately, but yeah, works very closely with us, and it's a health advocacy organization focused particularly on families and children and protecting their health from climate change and air pollution. So there's over 1.3 million members from lots of chapters. I saw the Ohio chapter has over 100,000 members, including a link there. And this group is really great at doing public advocacy to advocate for strong methane and health regulations. They often will have parents and sometimes small children give public testimony. And as a former regulator, I can tell you, it's extremely impactful when you have kids with asthma talking about their struggles personally and the importance of air quality regulations. So yeah, if you're interested in learning more, you can check out their link. So I think that's all I have on my presentation, and now I'm happy to take any questions.
Well, thank you. That was really educational for me, and I greatly appreciate it. Your perspectives, especially in this time politically and everything on the last part of your presentation there. It's always a difficult conversation. John, do you have a question?
Yeah, of course I have a question. I think, I mean, I have several, but one of the big questions I have is, what are the reporting requirements for these oil and gas producers? Like, in other words, like, what's the threshold above which they have to report? What forces them to actually report releases? Is it is it like a monetary fine or something like that? And is it to their best interest to kind of hide releases under the rug kind of thing, or are they good, at least in the United States, about reporting releases?
Yeah, great question. So currently there's the greenhouse gas reporting program. Subpart W is a specific one for oil and gas facilities. Um, any company that's part of that industry and emits over 25,000 tons of metric tons of carbon dioxide equivalents per year qualifies for reporting and has to follow a bunch of protocols on how to measure and report emissions. But for many sources, there are several options of methods that they can use to estimate emissions. Overall, the program, I think it does underestimate emissions because I don't think it's due to misreporting, more just some of the methods being used will miss emissions. And while I was at EPA, we tried to close some of those gaps. So one of the big ones is we added basically a super emitter category, a large release event. So something that's big that may be detected by things like aircraft that didn't fit into another category to include those. I don't think companies particularly cheat. I think they are trying to follow the protocol, but they're often, I've heard from companies that they don't think their data is accurate. They're following the methods, but like they use their own methods for other stuff, and sometimes they think they're under or over reporting emissions because of the methods in the law. But I think EPA was trying to make it better.
Yeah. So just
Okay,
sorry,
yeah.
I was just gonna follow up real quick. First of all, that was a great presentation. I should have started with that. I really appreciated it. It's really terrific. But you showed a picture of a methane release. Is that something that would have been reported, or
Ugh.
is that the kind of thing that kind of slips through the cracks, or an instance where you have, where the flare doesn't light, and so they're just emitting methane instead of burning it?
It's probably pretty easy to fall through the cracks. EPA tried to account for those kind of situations. So technically, yes, they have to report it, but it would be pretty easy for first the operator not even to know about it if they aren't collecting the right data. So yes, I think a lot of these things are not reported, but I think it's more due to like ignorance rather than like intentional misreporting. But yes, that's why you need more and more measurement data so you can really accurately report these emissions. And then now I'll give some bad news, more bad news. Yeah. So the Trump administration has proposed to get rid of the greenhouse gas reporting program. Again, a 10-year delay for oil and gas, but the intention is probably to kill the program. Everybody absolutely hates the idea. The oil and gas industry, including American Petroleum Institute, which is normally very anti-regulatory, wrote, sent comments are like, please keep this program. They used the reporting program not only for government reporting, but for a lot of their investors, for certain states. Was going to feed into the European methane regulation. So it is a tremendously stupid idea to get rid of this reporting program. Unfortunately, I expect the administration to not listen to the tens of thousands of comments about how stupid it is, and probably just they're going to get rid of it for ideological reasons. But currently, the University of Texas and Colorado State University has been talking to operators, and their tentative plan is to basically duplicate this program and collect the data if the government does not. And then hopefully if the administration changes in the future and is more science evidence-based, that they'll take the program back into the federal government.
Glenn?
Great.
Glenn, unmute yourself.
Uh,
All right, we'll try Helen then. Come back to Glenn.
Hi, great talk, David. I have a couple of questions. When you were talking about the decrease in emissions during the decrease in oil price in COVID, you mentioned like you hypothesized that was because there was less new production. Why is it that super emitters are mostly new production?
yeah, I think particularly in the case of the Permian, it's due to the, I think, overpressurization of the pipeline. So these new wells have very high production, and I think due to high oil prices, the operators were drilling these wells before they actually had the pipeline and gathering infrastructure to import to get the gas out of the basin. So this caused really high pressure in the lines, and then sometimes would basically cause things to pressure relief valves to go off, and then sometimes cascading problems like a processing plant might need to do some repairs so it can no longer take the gas from the tens of thousands of wells it was previously connected to. So those wells back up, get over pressure, and then giant emissions coming out of them. So yeah, I think and I have to be very careful how to say this. I think I testified in Congress about this issue. So I'm not saying to build more pipelines, but I am saying there are situations in which more pipelines would reduce emissions, and you should not be drilling new wells unless you have the pipelines to get the gas out of the basins.
Okay, thanks. That's interesting. And my other question is, with like your remote sensing measurements, being able to like reach out to the operators and let them know they have leaks, like what's it like collaborating with them in that way?
Yeah, so there's been a huge change over the last 15 years or so. So yeah, originally very skeptical, particularly EDF, and why we want to talk to an environmental group. But as they worked with us more and more and saw that we were science based, I think most of the large operators started really understanding that they had a lot more methane emissions than they knew about, and that they could measure and fix these emissions. And now I think particularly the larger companies, the kind of transnational companies that are exporting fuels to other countries, they take methane seriously, and I think they are trying to reduce their methane intensity. Oh man, I'd be curious to see how many of the PhD students that have gone through, done research at EDF, how many of them are now working for oil and gas companies. It's probably pretty high, but yes, they started getting a lot of these experts in-house so they could really understand it. But there are tens of thousands of oil and gas companies in the US. Most of them are really small and still don't answer our calls. So it is, yeah. So like it's a huge range from billion-dollar companies to mom and pops that have a few wells. So yeah, it still can be a struggle to really talk to the smaller operators and help them understand that we're not trying to shut their business down. We just want to increase the efficiency, and there are scientific ways of doing that.
Okay, Glenn.
Thank you very much. Thanks very much for the presentation. I wanted to ask a couple of things, and then the previous question brought something else up. What's the total amount of methane reserves that the U.S. has? I mean, we can calculate how long we have for oil based on our oil reserves and our daily production, about 10 years of U.S. gas or oil left. How much natural gas do we have left? Do you have any idea?
A lot.
A lot. Okay.
Yeah. Unfortunately, I think, especially in the Permian, we're not going to run out of oil or gas anytime soon at the Permian. So,
Okay.
so I think, yeah, it is really important to reduce, and especially now with the war causing really high prices. that could incentivize drilling in basins that were less profitable before. So yeah, I need to really make sure that there's low methane. I saw Amy just posted an estimate.
Appreciate it. But also in health and safety, there's a real as we're in health and safety, we try to emphasize the financial interest of saving people's health and health. The same thing could be used with this methane. How much is lost to oil companies each year by methane that is either burnt off or emitted?
Ooh, good question. I used to know that for the synthesis paper. I think it was $2 billion a year, something like that. But yes,
That sounds pretty amazing, doesn't it?
it's a lot of yes, a lot of lost profit. And I
Yeah.
did see the International Energy Administration just did a methane report, and they were using a lot of Trump language. So they're, I guess, trying to be convincing. So really, rather than focusing on the methane emissions, they were focusing on the lost energy and revenue from the emissions.
And then with that sort of losses, you think despite pipelines having to get approval, there's other storage facilities would be would be a place where you could pressurize the gas in site or something like that. Have any of those sort of innovations been taken up by the companies?
None that I've heard of beyond I guess the two ways are often the underground storage facilities for more utility gas. So often there is gas stored underground for that, but it's more about kind of the seasonal imbalance of consumers using natural gas. And then potentially they could store some of the gas as LNG. But yeah, I haven't heard too much. I think if anything, there's more research going into like CO2 sequestration. So kind of CO2 that they get during like processing things, using that just to store for carbon credits or kind of enhanced oil recovery. But I'm sure there's probably a lot of research into that now with the volatility in energy markets.
Again, thank you for a great presentation.
Does anyone else have any other questions? All right. Well, thank you very much for your time and a great presentation. It was really eye-opening to me.
Well, my pleasure. All right, have a great day.
Thank you.
Good job, David.
Thanks.